Hello everybody. The topic of this section is inflation and discounted cash flow analysis. In former section, we do not consider the effects of inflation, but we have recognized that the prices of goods, services, and assets must be corrected for the effects of inflation in order to make meaningful economic comparisons over time. In this section, we will discuss how to correct the effects of inflation for the discount cash flows. In order to take account of both interest and inflation, we distinguish between nominal and real interest rates. The general formula relating the real rate of interest to the nominal rate of interest and the rate of inflation is 1 plus real rate of interest is equal to 1 plus nominal interest rate divided by 1 plus rate of inflation. Or equivalently, the real rate of interest is equal to nominal interest rate minus rate of inflation altogether divided by 1 plus rate of inflation. Using APRs with continuous compounding simplifies the algebraic relationship between real and nominal rates of return. That is, with continuous compounding, the relationship between APRs becomes real rate of interest is equal to nominal interest rate minus rate of inflation. From a financial planning perspective, there is a great advance to knowing the real interest rate. This is because, ultimately, it is what you can buy with your accumulated savings in the future that you care about. For example, at age 20, you save $100 and invest it at a dollar interest rate of 8% per year. The savings are not to be taken out until age 65. What we really want to know is how much you will have accumulated in the account when you reach age 65 in terms of real purchasing power. One way we can compute the future value using the real rate of interest. Firstly, we compute the real rate of interest by the general formula relating it to the nominal rate of interest and the rate of inflation. That is, the real rate of interest is equal to 0.08 minus 0.05 divided by 1 plus 0.05, which is about 2.857%. And then the future value of the $100 using the real interest rate of 2.857% per year for 45 years is defined as the real FV. Is equal to 100 multiply 1 plus 2.857% to the 45th is $335. Alternatively, we can compute the nominal future value using the nominal rate and then deflate it to find the real future value. So we can compute the nominal future value by using the nominal interest rate of 8% per year at first. The nominal FV in 45 years is 100 multiply 1 plus 8% to the 45th and is $3,192. Next, we figure out what the price level will be 45 years from now if the inflation rate is 5% per year. The price level in 45 years is 1 plus 5% to the 45th and is 8.985. Finally, divide the nominal future value by the future price level to find the real future value. So the real FV is equal to the nominal FV in 45 years, $3,192, over the price level in 45 years, 8.985. The end result is the same with the one in formal method. It is found that by saving $100 today at age 20 and investing it for 45 years, we expect to have enough at age 65 to buy what we would cost $335 at today's price. In many financial problems, we care more about the present value. For example, suppose you plan to buy a car 4 years from now and want to invest enough money now to pay for it. Say the kind of car you have in mind now costs $10,000, and the interest rate you can earn on your money is 8% per year. If inflation in car prices is 5% per year, how much do you need to invest now? So we should try to figure out the amount to invest now, and the inflation will be taken account. Like the future value, there are also two equivalent ways to calculate the present value. In method 1, calculate the real rate of interest by the formula introduced in formal, and it's about 2.857%, and then apply this real rate to compute the present value of $10,000. The PV is equal to 10,000 divided by 1 plus 2.857% to the fourth, which is obtained $8,934. The second way is to compute the future value using the inflation rate and then find the real present value. So the FV at inflation rate is computed first. It's equal to 10,000 multiply 1 plus the inflation rate 5% to the fourth, and is $12,155. This means the car will cost $12,155 after 4 years. And then we can get the present value of the $12,155 using the nominal discount rate of 8% per year. It's 12,155 over 1 plus 8% to the fourth. Either way, we get the same result. You must invest $8,934 now in order to pay the car's inflation price in 4 years. In summary, we have studied the formula of real rate of interest relating to the nominal rate of interest and the rate of inflation. The calculations of real FV and PV are discarded by two methods. That's all about this section. Bye.